Good day, everyone. Today we're going to talk about central tendency and dispersion, probability and statistics. In this lesson, we're going to dive deep in central tendency. We're going to become familiar with dispersion, and we're going to demonstrate a analysis presentation. All right. So here are the announcements for the discussion of the homework. I gave homework to you guys last week. It's due on Thursday. Make sure you have it done. We're going to discuss a possible field trip to NASA, which is coming. Um, Last year I did talk to a certain amount of you about the field trip, but I ultimately decided to give it to the seniors last year who was taking my course, and I decided to bring Mr. Broussard along as his few good students. As you might be paying someone a visit, any missing work that you are missing, you're going to have to complete it online, or I may just give you the paper version of it. But y'all listen up. If you're missing a lot of days, seat time will occur, or you're going to fail the course. Um, I am sympathetic with some of you guys who work nights. I'm very patient and understanding about that, but I still need you to come to school because unfortunately, every time you miss, you're going to be it's going to count against you. You know, some of you guys missed more than 10 days already during the first 9 weeks. I was cool with you, but this is second 9 weeks. I can't do that. So please bring yourself here. I will be reaching out to y'all through your parents, telling you, hey, be here. Because, I mean, not all teachers are going to give you the pass, and you guys know me well enough to know that I'm not one teacher who's going to just give you a passing grade. Either you're going to earn it or you're going to get thrown out. All right. Communicate through Google through anything. Yeah, please do. Please, please, please do. We're going to start. I don't know why I've been spell reviewing, but oftentimes misspell things. We're going to start reviewing Algebra 1 and Algebra 2 skills. The reason why we're going to go back to Algebra 1 and Algebra 2 because all that stuff that you learn in Algebra 1 and Algebra 2, the majority of it going to fall anyway in statistics. And you guys know this from regression because our regression was dealing with functions that we call models today. Remember, in statistics, functions are not called models. Now, your project. A good number of you have did some killer teamwork and got things done. People who are absent, you're going to have to do something extra to receive a grade in terms of the project because, I mean, most of the people who was working on the project pretty much almost done with it. Now, wherever I teach today, you guys who were absent, you are responsible to include it into the project. If you fail to do that, you're going to catch this F. Now, I've been chill with you guys, but y'all please don't bring me back to the Algebra 2 teacher Howard. Y'all know how I got down. Don't bring me to that, so just do right by me. You must do your equal share to receive a grade. If you keep missing days just for the sake of missing days and not communicate with the class to getting the project done, you're going to fail. Some of you don't got the grades that you really want because this course is too easy to fail. And I'm intrigued if you got a D, even if you got a C, it's really unacceptable because the course in itself is not hard. I mean, remember, y'all survived Algebra 2 with me. Y'all had worse. All right, so look, in math and even in statistics, you're going to be seeing a lot of Greek letters. You're going to see a lot of it. In Algebra 2, you saw some of it in Trig. I know Miles probably mentioned it. I try not to bring that to your attention because I was so busy trying to get you to understand the skill and not get caught up on notation. But in statistics, because you guys have passed 1 and 2 and did it well, you got no notation. So the important letters that you're going to be dealing with, you are going to be dealing with pi, sigma for sure. You're going to be dealing with delta. All right. And this is all I'm gonna show you for now. When you guys choose to go to college or what have you, you're gonna be familiar with these Greek letters. And I know you heard of sororities and fraternities. This is what they use. They use Greek. All right. So you're gonna be dealing with. I know we know this in mathematics to be known as pi being the decimal point of 3.14 or at 22 over 7. But in statistics, that has a different meaning. All right? Because this deals with, just proportions. When you're dealing with mean or average means, you are dealing with this thing called mu. Mu for population, and for sample statistics, X bar. You see population parameters as sample statistics. I don't want to distinguish too much from these because these are all in particular cases. Like population, of course, dealing with people. Simple statistics could be dealing with, you know, money, sickness, or those kind of things. But I may or may not spend too much trying to distinguish between the two. Variability, but you do need to know this symbol and definitely the mean symbol. Pretty much you need to know all these symbols. SE, I don't too much care about that. Then that's something I'm going to get involved with. But population size, definitely know these letters. Okay? I guess we could, go further with population parameters and simple statistics. You just gonna know based on the given situation. Alright? But I don't want to spend too much time on that. Just be familiarized with those symbols. Alright, again with data. Like, I know we've been doing central tendency a bit. And I know it is a middle school skill, but I'm just gonna be honest with you. I know for a fact your math teachers, I could say this with confidence, 99%, well, 100% confidence, none did not teach you statistics. None. I would say I may be 1% wrong, so 99% chance I am correct. Most they teach all other skills, but statistics you don't really see it. Maybe in elementary, middle school you know about, well, in middle school for sure. Maybe you had a teacher who taught you how to find, mole, mean, median, but you just have never seen it again after that middle school level. I know in your geometry class y'all didn't talk about probability of any caliber, so I'm familiar with that. So the reason why we talk about central tendency and now dispersion measures, because we gotta know them in relation to the data types that we're dealing with, or the measurement of data. So nomial data deals with categories without order. So when you are dealing with this kind of data, your central tendency, you are mainly looking for the mode. And then the dispersion is limited to the frequency of the distribution. Like for example, like eye color. It doesn't have a particular order, it's just eye color. You know? ordinal, ordinal data categories with order. So this does use the median and the mode. It's very applicable. But when you talk about dispersion, you talk about the inner quartile range, and I am going to explain to you what dispersion is. If you could look at the word, if I said the word disperse, everybody disperse from the classroom, you know what that means. That means to separate. Everybody, spread apart. Mainly to spread apart. That's what it really means. So dispersion deal with your inner quartile range, which is very appropriate. Your example, you could use education level. High school, your grade level is in order 19th, 11th, 12th, seniors, juniors, sophomores, freshmen. Interval data is ordered with equal intervals. So all measures are applicable, so not just central tendency, but dispersion as well. And when you talk about like temperature, it's a good example, you know, or Celsius or Fahrenheit. We use Fahrenheit in the U.S., but other parts of the world use Celsius. Celsius, sorry. So, and there's other examples you could think of, you know. Ratio data. We know what ratio means. In pieces, parts of. Like for example, if you're talking about height could be 5 feet and 2 inches. It's a ratio because you got that 2 inches because it's part of. Your weight, your income, $48,000, $29.10. That's a ratio. That's a ratio. Now, again with the box plot. Again with that, huh? Miss Howard, I don't get it. Why am I using all this? Well, the box plot is gonna play it's gonna play into all parts of the lesson. Central tendency is all statistical measures that describes the center. So central tendency is a statistical measure that describes the center. Mode, meaning. But I want to bring this to your attention. Mode Mode is not necessarily a central tendency. I mean, it's really more of a frequency, really. Here's why. Think of it this way. In your calculator, when you put all this into the calculator, do you see mode? Does it give you the mode? No, because it's not really a central tendency. You're supposed to know frequency yourself with your two eyes that God gave you. If you go to Desmos, you'll see the same thing. Mode is not there. You can't find the button that says give me the mode because you can see it. It's right there. All right? So let's talk about how data is distributed. So I know you guys by now are familiar with the histogram because that's what we've been doing. We've been using histograms. So have you wondered about how the visuals look of a histogram depending on your data? Sometimes you may have data that looks like this. Sometimes you may have it look like this, or sometimes you may have it look like this. So let's look at the first one. If you look at the first graph, you see how all the values and all that stuff hits at the right. Well, if you look at the second one, you can see all the big values going to be at the left. And then, if you look at the far right one, you see it's all over the place. It's high, low, high, low, high, low, all this, all that. But everybody, objectively, we want our data to form a perfect shape. And when it has this perfect shape, that just means that you have no biases, no strange looking data at all. And that means that your data is a normal distribution, meaning that it distributes perfectly. That's the data that we always seek. I always wanted to have. We want perfect data. And we know in real life that's not going to be the case. Sometimes you're going to have data that falls like this. You're going to have data that falls like this. You're going to have data fall like this. And this is called a normal distribution bell curve. And I know you're going to hear people talk about the bell curve. The bell curve is something that is really the bread and butter is really going to tie into our probability stuff as well. So that's why I'm bringing this up because we are going to spend our units of probability and we need to have this down first. All right, so let's talk about the bell curve distribution. So bell curves are useful for quickly visualizing data sets, mean, mode, and median. It's great for comparison of categorical data that uses central tendency and dispersion. If data tends to be around a central value with no bias, left or right, then the visualization is shaped into a bell, which I have spoken to you guys about. It shows the probability distribution of a set of data. And this is something that we are going to get into before we get to all other forms of probability. All right. So look, this is the bell curve that we are talking about. So let me bring it to you in real life. So this center, and you guys been in school long enough, this is how we, describe you guys in terms of testing. You know, testing because back then your leaf scores, everybody needed to be an average performer. Cause average means you were basic. Low performers were scores unexceptional and approaching basic, and high performers are, mastery and advanced. But this doesn't also apply to grades, this also applies to real life. You know? And you're going to see how this works in both central tendency and dispersion. All right. So let's talk about skew left being negative. So when we say skew left, here's what we are saying. We are saying that the tail of this data that drags in, that means that's where a few people scored or something like that if you want to go there. Because the tail is being dragged to the left. This is what the tail is going. It's going left. That's where we got left from. Now, negative. Here's my explanation of negative. Because your mean, your average, is lower than your median and your mode. Anytime your mean is lower than your median and your mode, it is a negative left skew, because that means that, your fewer people score is going to be going towards the left. Again, if your mean is smaller than your median and your mode, it's going to be a left negative skew. All right. And this is just a detailed example of a left skew distribution. When the distribution have a long tail towards the left side, this is known as a left skewed or negative skewed distribution. In the negative skewed distribution, the concentration of the data points towards the left tail and more is on the right tail. And that's just, again, a repetition of what I stated earlier. Now, as I told you guys before, our goal with data, again, data is its own character. It don't bow to nobody. But when we get perfect, well, not perfect data, but data that's symmetric, and most of everybody hits within the mean, and this means that your mean is equal to your median and your mode. This is a barrel shape, and it's symmetric. So this is called normal. Don't worry about normal distributions. We're going to get to that later. But right now I need for you to know when your mean, your mode, and your median are all equals, you got a bell shape. And yes, it is symmetric. So you could just call it a bell-shaped skew, or you could just call it a no skew. Now, when it is when you have a mean that is higher than your median and your mode, that means you have a skewed right positive. Again, if your mean is greater than your median and mode, it is right skewed and it's positive. And again, it's positive because the tail drags on that way to the right. Well, really it's positive because your mean is the greatest. And we call it a right skew because the tail drags at the right. All right, this is just a detail what I have stated. When the distribution has a long tail towards the right side, then it is known as a right skewed or positive skewed distribution. In the right skewed distribution, the concentration of data points towards the right tail is more than the left tail. So again, your mean is higher than your median and your mode. So these are the two tails. All right. Now, if you understand all of that, you should be good. Because you know, in the right skew, your mean is greater than your mode and your median. Your left skew is when your mode, your median is less. No, I'm sorry. Your mean, forgive me, is less than both your mode and median. All right. So, suppose you did a project for me and it's 100 points, but you scored a 50. I need for you to make an inference based on what you just learned about skews in relation to your grade. I want you to pause the video and see what kind of conclusion you can make. All right. Since this graph is the right skew, a right positive skew, that means that the average is above the median and the mode. So that just means that the average, that means I'm at the average. So that means the average grade was 50. I was within that average. So looking at this graph, looking at this visualization, that means most of my people failed my test. Project. So most failed the project. That means that the 50, I'm within the average score, which was 50. All right. And this is just more visualization of the same stuff I've been saying. So a left skew means my mean is small, lower than the median and the mode. A right skew means that the mean is greater than the median and the mode. All right. So we're good with that. Good. But I do want to talk to you about the misconception of the independent variable when we was working with the strawberry data. So my question is, how can you do central tendency with both? Because I saw that you guys were trying to, you know, get the central tendencies with the bags. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, the independent variable doesn't work in this case. So when you are doing your analyses, you cannot use your independent variable because you care about the dependent variable, and we know the dependent variable is your outcome. So which one of these are the outcome? The strawberries, because the strawberries, you know, just look at the numbers. It's not going by one, it's going all over the place. 10 to 13 is going by 3. Then it goes by 2, 4, and then all of that stuff. So that's what you want. You want that. You don't want the independent variable. You're going to talk about the independent variable in your analysis, but your main focus is the dependent variable. So what you should have did by now, you should have just got the strawberry data. just the strawberries. You're not caring about the bags. And this is just me just telling you that you cannot be focused on nothing else but the dependent variable for the essential tendency and your dispersion. So I do want to show you guys how my graph looks like when my histogram looks like when I put in decimals. So when I put in decimals, this is what I got. This is what I got. Pretty, isn't it? And this is how I label them. Because when y'all do your presentation, I do want you to, if you are when you are using decimals, I do want you to get a nice little shot, a good, easy visualization. I want your visualizations to look good. I'm gonna show you the tricks and everything. So I want you to determine the distribution, the skew of it. So pause the video and try it out. By now, you should have went to decimals, put out the central tendency to figure this out. So your mode is 11 because it has the most frequencies. Your mean is your 11.22 and your median is 11. So it's a positive skew because, like I told you, when your mean is bigger than your mode and your median, your it becomes a positive skew. So that means that it looks something like this and it looks something like that. So that's what I want you guys to understand. We good? Good. So what happens if and only if you add 9 to the data set? So go back to your strawberries and add 9 to it and see what happened to that distribution. Pause the video and try it out. Welcome back. So let's discuss. So the mode, the mean, and the median becomes the same and it has a normal distribution. And that normal distribution is a bell curve. Easy. And in your presentation, you have to be able to have that talk. Dispersion, the spread of the data. Now, this is one of the last things that I want you to include in your project. Now, again, if you was absent, you are responsible for all these things that is being taught today. You have to make sure that that's included into the project. You are responsible for it now. All right. So, dispersion means the extent to the numerical value is likely to vary about an average value. In other words, dispersions help you understand the distribution of the data. This includes your variance, standard deviation, range, In the quartile range 1, in the quartile range 3, you're in the quartile range. In your calculator, it does all that calculation. In Desmos, I believe it does do the same thing too. But I need for you guys to include this in your presentation. So first and foremost, let's talk about the range. It is simply the difference between the maximum value and the minimum value in a given data set. So you subtract the highest from the lowest, you get your answer. Quartiles. Quartiles are the value that divide a list of numbers into quarters. The quartile deviation is half the distance between the third and the first quartile. Quartiles divide the entire set into four equal parts. So there are three quartiles, first, second, and third. And this is represented Q1, Q2, Q3 respectively, which you should have saw in the calculator by now. Q2 is nothing more but the median, since it indicates the position of the item that in the list, and thus a positional average. To find the quarters in a group, we must arrange them in descending order. In all honesty, you don't have to do all of that. You got the software to do that for you. Because I want you guys to learn in statistics. Everything is all pretty much just doing it in the software. Your main goal is to explain the meaning and the interpretation of these skills. Alright, this is a box plot of the strawberries we worked on. What I want you to do is give me a quick little analysis on it. Pause the video and analyze the stuff we just talked about in terms of the quartile ranges and stuff like that. And put it in this context of the bag of strawberries. And pause the video to do it. Alright, this is what welcome back. Hopefully you did what I needed for you to do. So this is what was done. So, in the context of the data, the amount of strawberries in the bag ranged from 7 to 15. A fourth of the bags consist of, at most, 9 strawberries. And 3/4 of the bags contain at most 13 or 14 strawberries. The difference between the bags falls to 8 strawberries. So this is me taking what I just did with the inner quartile ranges and the maximum and that range, and I talked about how the data is, spread it. They spread it just like that. All right. The only thing that I may want to disagree with myself about is when I said the statement is difference between the bags would be 8 strawberries. So I'm gonna let you fix that one yourself to reword it or repurpose it. But when you find your range, subtracting the biggest from the smallest amount of strawberries, I need for you to reword this in a better way. All right. So let's talk about variance. So variance has a notation. we're going to deduct the mean from each data in the set, square each of them, and add each square, and finally divide them by the total number of values in the data set to get the variance. So, well, I'm basically, long story short, I'm trying to find the means of each um, piece of data in the data set. Like, say, for example, if I was looking at grades or whatnot, you know, if I was trying to find the variance, I would just compare the averages from everyone else. So, like, say if I was to take, I would take students A average and do the square to find the variance of that student A. And I will explain to you momentarily about the importance of variance. So here's the importance of it. By examining customer trends and preferences, variance analysis help companies create new products. So businesses can find chances for new product innovation, customize product features, and raise consumer happiness by looking at the variance in the market data, such as sales numbers or customers' feedback. Variance is like a handy tool used in everyday situation. So this is what I want you, yeah, this is what I want y'all to get in day-to-day operations. They use variance to kind of, see about improvements. So, you know, when you are doing hair care, you think about, the best product for your customers based on how satisfied they are with it. And the variance, play a big role into that. And also help us with managing risk. Sometimes you try to figure out, how many people are upset about, a hair product, It just help us to understand, people being upset and help us to manage the risk by reducing the risk. Like you may have some, you know, hair product that have a smell to it, that sulfur smell, you know? But in the field of finance, it helps us assess how risky investments might be and guide decisions to where to put money as well. So for my future business owners, variance play a part into all of this. Standard deviation is the square root of the variance. And in short, all the standard deviation is saying to find the difference from the mean. All right. So talking about this data that we did with the grade, you know, so we made some conclusion that the average was like 50, and we were saying that we was within that average. So the deviation it talks about how far away I am from the average. So if I scored a 20, I'm far away from the average, am I not? I am. So that's what it means. All right. I want you to try this with me. This data set shows the average pay rates for several employees at a restaurant. I want you to find and interpret the standard deviation of the data set. So pause and let's find out. Welcome back. By now, you should have found the standard deviation to be 90. And because it's zero point 0.9, which is 90, in this case 90 cents, this means that the typical hourly pay of an employee differs from the mean by 90 cents. So you like, how did you, how can you say it different from the mean? And we didn't calculate the mean. Well, the standard deviation tells you again how far you are away from the mean. And so when you get the standard deviation, you are using that number and say you are that much away from the standard, from the mean. So bring it back to school. Ideally, this is how the grading scale was designed. The grading scale was designed like this. Its purpose in mind was that, or still is, everybody falls into this category because when you have a C, that means that you do know some material. You have an okay knowledge of the material. That you could pass some tests. If you score a B, that just means that you have a little bit extra. So you are above the average. If you have an A, you are far away from the average. If you are a D and F, you definitely know what's up, but everybody, the goal of the education system, everybody needs to fall into that C, having some knowledge. D means you pass too, but doesn't really necessarily mean that. It means that you're going to struggle or you struggled. C means that you didn't struggle. You struggled just a little bit, but you didn't struggle as much as the person with the D or the F. All right, so another real world situation is like teacher evaluation. So, in my evaluation, everybody wants to fall and meet expectations. Most likely, every job, not just my teacher evaluation, but every job has these categories when they evaluate you. Meet expectation means that you know exactly what's up. You doing the job just enough. Rule from improvements, you have a few issues. Unacceptable, you pretty much about to get fired. Meet expectations, you go up and beyond. Outstanding means that you were really killing it. And again, this is just a result. So that means that if you are above the average, that means you are 10 more, you are more impactful, 10 times more impactful. But if you are like a person who don't do their job well enough, that means you are more 10 times more problematic. All right. So this is what I want you to do now. I want you to use this data set ATM withdrawals. I want you now to do all your central tendency and your dispersions of it. And I'm going to end it here.